Hello folks, and welcome to this video demonstration of Dot by Awen, our asset and vulnerability discovery solution for operational technology. My name is Jules Farrow-Lesnianski. I'm Awen's CTO, and I'm here to give you a bit of background on Awen and Dot before giving you a walkthrough of its technical features and capabilities. So to begin, who are Awen? We were founded in 2017, and our aim is to make society safer by reducing the impact of cyber attacks on our critical national infrastructure, manufacturers and defence. Basically, all the services that we rely upon on a daily basis, including water, electricity, transport, healthcare, and of course their supply chains. We do this by creating software solutions, and we're here today to talk about Dot. Dot itself is focused on giving you in-depth visibility of your OT assets, sufficiently to identify each of them and their inherent cyber vulnerabilities. Dot was initially born out of an innovation project we completed with Raytheon UK, followed by a project with the UK Ministry of Defence and tested in partnership with Thales. We've been supported throughout by the UK National Cyber Security Centre, and in 2022 we announced our partnership with industry giant Siemens. Dot has been developed to make it as easy as possible to reach 100% visibility across your OT environments, working around many of the constraints which OT networks often have, including a prevalence of legacy technology, widely geographically distributed networks, or limited bandwidth infrastructure. Because Dot focuses specifically on asset and vulnerability discovery, we don't require real-time centralized network data in order to provide value, significantly simplifying our deployments, lowering complexity, increasing flexibility, and of course, reducing your costs. Most organizations we speak to aren't yet ready for a real-time intrusion detection system. They're taking their first steps into OT cybersecurity, and the first item on the agenda is visibility. How can you protect something that you don't know anything about? Dot's focus is to provide you with that understanding of your current OT cyber maturity, where exactly your risks lie, and therefore enable you to mitigate them before an incident occurs. The OT systems that we protect are often inherently insecure due to their life cycles being much longer than typical IT equipment, and most have no ability to utilize concepts like authentication or encryption, and many are relying on legacy IT infrastructure with known vulnerabilities baked in. Alerting to potential intrusions is unlikely to reduce your risk in those sorts of contexts. However, an in-depth understanding of your risks and how to reduce them ahead of an incident occurring, of course, will. Dot gives you that visibility and allows you to monitor and manage your assets and vulnerabilities on an ongoing basis to prioritize and track your risk reduction over time. What we'll do now is jump into our demo of Dot and walk you through its features and capabilities to put that into context. The dataset used in this demo, kindly shared with us by our partners at Booz Allen Hamilton, focuses on a network of 51 assets across 21 different vendors, upon which we've identified almost 350 known vulnerabilities thus far. We've identified 15 different protocols in use across this network, and we'll be digging into a few of these OT-specific protocols throughout this demo, including Ethernet IP, Siemens S7Com, and Modbus. Of course, Dot supports many more OT-specific and generic IT protocols, and that list is growing all the time. One of the most important changes to Dot's dashboard for this version 2.0 is the most vulnerable assets table. To prioritize your risk mitigation efforts, we combine the importance of your assets plus the known vulnerabilities for each of them to give you an idea of where your limited resources are best deployed to reduce your OT cyber risk. Whilst the dashboard here is great for giving you a high-level overview straight from the web interface, one of the most highly requested features for version 2 is the ability to take this data offline in a readable format. Therefore, we're here to introduce our new Highlights PDF report. This report can be generated at any time to give you a view on the assets, vendors, communications across your OT network, protocols, vulnerabilities, and OT cyber risk, all in this shareable PDF format to take to your next meeting. Right, back to Dot. A quick note that all of the data within Dot can be separated by sites for ease of visibility through this drop down here on the top left hand side. Moving on to the Network Topology tab, we have a visualization here to help you understand the IP connectivity between your assets. Nodes are given a friendly name where possible, else their MAC address is shown. You can add additional labels over here, including their last known IP address. As you can see, the vast majority of the network communications are centered here around this engineering workstation, and we have a number of devices around the perimeter where we've only seen broadcast or layer 2 traffic, or very limited device-to-device communication. As well as this view, we also offer one based around the Purdue model. This should be of interest to anyone looking to adhere to the IEC 62443 standard or the UK HSE's OG86 requirements, or of course if you're just planning to segregate your OT networks to reduce your cyber risk. The Purdue model has two use cases. Firstly, if like this example, you currently have a flat network with no segregation, you can use this as a planning tool to identify how to redesign your network using the model. Alternatively, if you're undergoing a network redesign at the moment, you can utilize this view to validate that your design is aligned as you would expect it to be. Networks can be identified automatically by analyzing network traffic or added manually. To generate the model, first we identify the asset, then its type, from which we infer the level it should sit in the Purdue model, and then build your graph. Users of Dot have found it really valuable to visualize their network in this way. For example, if we were planning to place a firewall between levels 1 and 2 here, Dot would enable you to export all of the connectivity data between the assets on those two levels, thereby essentially generating you a firewall rule set ready to deploy. Let's have a look at the kind of metadata that we can identify about these assets and where it comes from, starting with this Rockwell Micro 820 PLC. On the right-hand panel here, you can see the depth of data we're able to discover about this asset, including its vendor, model number, individual unique serial number, and critically, its current firmware version. This is an ideal scenario for us, as all of this data can be identified from a passive scan of this network, or even just by uploading a PCAP to Dot. Let's have a look at the underlying network traffic data and where our metadata has come from. These are all of the Modbus packets coming to and from this device. Nothing too interesting to see here. Our Micro 820 is reporting a value back to the Micro 850, but it does enable us to understand the hierarchy between these two devices. For those intimately familiar with the wonderful world of Modbus packet headers, the UID column here isn't utilized within a Modbus TCP network like this one, but it does come into play within a Modbus serial network. If, for example, we had a gateway between an Ethernet network that Dot was monitoring and an older RS-232 or 485 Modbus network, this would allow us to identify each of the individual assets behind that gateway, giving you visibility with Dot beyond the confines of a modern Ethernet network. Looking at the Ethernet IP traffic for this device, here is where the vast majority of our metadata is coming from. Once every second, this device is sending an identity packet to the engineering workstation. Dot can analyze that packet and extract the information that we need. Ideal for Dot, not so great for cybersecurity. If Dot can read it, so potentially can someone scouting that network for more nefarious purposes. So, with my cybersecurity hat on, my advice would be to turn off that functionality if at all possible. So let's have a look at an example of where that's already occurred and how we can work around it from Dot's perspective. This device here is a Siemens S7-1200 PLC. However, all we've been able to pick up about it from a passive scan is that it's definitely a Siemens device. It's not that we can't read the packets. There are over 185,000 of them that we can look into, it's just that none of them are giving us any information about that asset itself. In this scenario, we can utilize our scraps capability. SCRAP stands for Safety Critical Active Protocol Scanning, and it essentially enables us to communicate safely with this device to extract the metadata that we desire, all without affecting its functionality or that of any other device on the network. It's very simple to utilize. We click here and then OK to confirm. As you can see, the same level of metadata can be discovered, enabling us not only to identify this asset, but also deduce what known vulnerabilities are relevant to it based on its current firmware version. Dot does the heavy lifting for you, searching across public CVE databases to bring you relevant vulnerabilities for this device. Once an asset has an identifiable vendor and model, Dot will prompt you to search for its vulnerabilities and bring them all together here on the Vulnerability tab. The aim here is for you to be able to prioritize these against their relative risk to your organization. Dot uses two criteria in order to help you to do this. The first is the CVSS score for the vulnerability itself. You can see the vectors used to calculate that score here, and even edit these to suit your individual organization if you happen to know an additional factor which mitigates some of this risk already. The CVSS score helps answer the question, is this a dangerous vulnerability? But not, is this dangerous to my organization? To do that, we need to combine the CVSS score with a relative measure of the impact of compromising this device. As OT prioritizes the availability and integrity of an asset, it's often a question of what impact it would have on your operations if this asset were to stop functioning correctly. Would it stop your entire facility's operations? Could it be manually overridden whilst a cause is investigated? Would there potentially be a safety issue? The answers to these questions will need to come from an engineer within your facility with an understanding of your operations. The value here comes from bringing that cyber knowledge and operational knowledge together to move from measuring vulnerabilities to measuring risk. Risk is what your organization's management is interested in understanding and reducing, and this is how you'll be able to identify and reduce it. Once you have prioritized your risks, you'll be able to find a summary and references to mitigation strategies, as well as assigning them to a member of your team to investigate and set a status against. So, how do we get network data for analysis into Dot in the first place? The easiest way is via PCAP. You could collect these using an open source tool like Wireshark from various points across one or more networks and upload them to Dot afterwards, enabling you to perform decentralized data collection but maintain a centralized asset and vulnerability management solution. This also enables us to provide Dot as a software as a service offering which can be deployed to you in minutes. Of course, Dot can also ingest live network traffic via Ethernet from a SPAN port or a network tap. This could be on a portable device like a laptop, or a permanent on-premise deployment like a virtual machine or running on dedicated hardware. Dot has minimal hardware requirements and can be run with resources as basic and affordable as a Raspberry Pi, but is also easily scalable and can handle large bandwidth applications with enterprise server hardware. We've already demonstrated our OT scraps capabilities, but offer two further tools here to help uncover more difficult to reach areas of your network. Our ARP scan enables you to uncover unknown network topologies and dormant devices with ease, and our ping sweep gives you the option of a safety-critical conscious, active-first approach to gain visibility where SPAN ports or network taps are challenging to deploy. On our settings page, you'll find controls for security features like two-factor authentication, and of course, all of our data is encrypted, both at rest and in transit. As many of the use cases for Dot would involve deployment in a non-internet connected network, we also now allow you to cache all of the vulnerability data locally to enable vulnerability discovery even in offline environments, and upload new vulnerability packs where possible to keep those definitions up to date. Our user management enables you to assign various roles to users to limit their accessibility to certain features and datasets, and the organization section allows you to work seamlessly with third-party consultants in a secure way. We've already mentioned the Sites feature earlier, but it's simple to create, delete, and migrate devices between them as you wish to ensure that you can focus on the areas most important to you. At the bottom of the page, you'll find the ability to send the alerts that Dot generates to a SIEM or syslog collector. Whilst many of our clients are using Dot as a standalone solution, if you're deploying multiple instances or integrating Dot into a wider security architecture, the ability to centralize alerting is vital at scale. Finally, we're always on hand to support our clients. We stand behind our solutions and want to ensure that Dot's potential value is reached during every deployment. We're always ready and willing to hear your feedback, and many of the features you've seen showcased today were a result of collaborations with our partners and our clients. Thank you so much for watching this demonstration. If you have any further thoughts or questions, we'd absolutely love to hear from you. Drop us an email at hello@awencollective.com or visit our website to book yourself a demo.